But the problem is that what? So for the user, it is a problem to give the instructions using that binary language. Using that binary language, giving instructions is very difficult. Okay, that's why what they have done, assembly level language was developed. It was developed. Okay, so in this assembly level language, so how can we give the instructions?
To the C++
by
Java.
using
High level language.
mnemonics, by using some mnemonics
Mnemonic.
and symbols, we can give the instructions to the system. Okay, that means if you want to add two numbers, you can give the mnemonic add, then after 5 and 6 you can give. Okay, that means what, giving the instructions using that assembly level language is easy to the programmer. But the problem is that again, the computer, it doesn't understand that assembly level language. Then what we need to do? We need to take the help of a translator. We need to take the help of a translator. Okay. So this translator is a program. This translator is a simple program. So this translator, it converts assembly level language into machine code. What it converts? It converts assembly level language or assembly code into machine code. Okay. So then after the machine executes those instructions, then we will get the output. Okay. That means what, we need to take the help of translator. The translator name is, what is the translator name? Assembler. Assembler is a translator. Okay. With the help of assembler, you can convert assembly level code into machine code. Okay. But again, what are the problems they have faced with this assembly level language?
If program size increases,
if the program size increases, if the program size increases, again it will be a problem.
Difficult to spot errors.
To spot the errors, to identify the errors, it is very difficult, and also to rectify those errors also very difficult. Okay. Then after what they have done, then that's why high level language were developed, like C, C++, Java. So all those languages were developed. Python, all those languages were developed. So these high-level languages are very similar to our natural language. These high-level languages are very similar to our natural language. That means what? So using our natural language like English, you can give the instructions to the system. You can give the instructions to the system. But again, the problem is the system, it doesn't understand those C language, C++ language, all those things, it doesn't understand. Again, what we need to do? We need to take the help of translators. We need to take the help of translators. What type of translators you can use? We need to take the help of compilers and interpreters. These two are the translator, compiler and interpreter. These two are the translator. Here the compiler, it converts entire code, entire source code at a time into machine code. Compiler, entire source code will be converted into machine code. Okay, so after that, if any errors are there in that source code, then it displays the errors message. Then you can modify those errors. Then the program will be executed. In case of interpreter, the interpreter, it executes or it converts line by line. That means the first line, it will be converted into machine code. Then after it will be executed. Then only it goes to the second line. Again, second line will be converted into machine code. Again, that line will be executed. Then it goes to the third line. Suppose if is there any error in the second line, without modifying those errors, the interpreter, it will not go to the third line. It will not go to the third line. It converts line by line only. Okay, it is easy to convert line by line, but it takes more time to convert entire code. Why? Because it is converting line by line. So if there is any errors, the programmer has to rectify those errors immediately. Then only that line will be executed. After completion of that line execution, then only it moves to the next line. Okay. So interpreter, what it will do? It will do, it executes or it converts line by line. But in case of compiler, entire code will be converted into machine code. But interpreter, it converts line by line. Okay. So that is the difference between compiler and interpreter. Nowadays, we are using compilers only as a translator. We are using compilers, right? Okay, I will share the screen. Wait. Okay. So before going to discuss about high level languages, so already we have discussed about the syllabus, all those things, right? Okay, let us see here. So already we have discussed what is a hardware, what is computer hardware. Is it visible to you, all of you?
Yes, ma'am.
Yes. Yes, read the second point. What the second point it is?
Concept.
This concept gives the complete information about components and usage of computers with respect to the program. So what are those components here?
Disks.
Disks,
Disks,
primary and secondary memory, processor, operating system, compilers. Okay, so that means what here you need to know about the disks. Already you know very well about the primary and secondary memory, and also we have discussed about the CPU. CPU is nothing but processor. After that we have discussed about the operating system. What is an operating system? It is a system software. It acts as an interface between user and the computer. Okay. Now also we have discussed the compiler. Compiler is a translator. This compilers we are using to translate the source program into machine code, right?
Machine code.
Now, so what is the definition of a computer?
Computer is an electronic device that takes data as input and gives
and then process that input and gives the
out.
result as a output. And gives
output. Computer is known
so
as
you need to give
hardware and software.
you need to give the input to the system. That input will be processed by the CPU. Then after it produces the output. Okay. So and also we have seen one more definition. Computer is a combination of hardware and software. Computer is made up of with hardware and software. Okay. So already you know what are the hardware components we are using to give the input, to see the output, and also for processing. Okay. So before going to discuss next topic, let me know what is a data and what is an information.
Data.
What is the difference between data and information?
Collection of information.
Data means what? Data is nothing but unprocessed material. What is data? Data is nothing but unprocessed material. That means suppose if you want to add two numbers, so 2 is a data, 3 is a data. Okay. After processing that data, that means after adding those two numbers, you will get the result 5. Okay. That 5 is the information. What is that 5? 5 is a processed data. 5 is what? Processed data is called information. Suppose if you want to take banana juice, if you want to prepare the banana juice. So here to prepare the banana juice, so what are the raw materials you need to take? You need to collect. Banana juice. I want to have the banana juice. I want to drink the banana juice. So to prepare that banana juice, what are the raw materials I need to collect?
Banana.
Milk,
sugar,
banana,
water.
milk and sugar. Only banana, milk, sugar. Okay. So there's 3 items. Water is not required. Now milk we are giving milk na. So if you want to add, you can add the water also. If you want to add, if you want to drink more juice, so you can add water also. But these 3 items are required: banana, sugar, and milk. Right? If these 3 items, okay, if you mix in that mixie jar, then what will happen? What you will get to? So you are processing this. That means you are combining these 3 items. You are mixing. You are trying to mix these 3 items: banana, milk, and sugar. Okay. So that mixing that jar by adding these items is called what? Process. It is called what? Processing. So after completion of this process, what you will get? After completion of this process, what you will get? Banana juice you will get. Banana juice you will get. Okay. That means that is a information. Processed data is called what? Information. Okay. What is the data? Data is nothing but unprocessed material. What are the unprocessed materials here we have collected? Banana, milk, and sugar. These 3 are the unprocessed materials. After that we have processed. That means we have mixed these 3 materials. Okay, in the mixie jar. Then what we got? We got the information in the form of banana juice. Banana juice. So that is called information. That means for processed data is called what? Information. So here, similarly here, 2 and 3 are the unprocessed materials. So after adding those two numbers, you will get the result 5. So that 5 is the information. The processed data is called what? Information. Unprocessed material is called what? Data. Okay. So that is the difference between data and information. That means what? Here you are giving the input in the form of data. The data you are giving as an input. Okay. After that, the CPU, it will process that data. That means if you want to perform addition operation or subtraction or multiplication, whatever it may be, the CPU will be processed that data. After processing that data or after applying arithmetic operations on that data, then you will get the result as a information. What you will get? You will get the result as a information. Okay. So data is what? Unprocessed material is a data. What is information? Processed data is called information.
Just
right?
data.
Okay. Processed data is called information. Here 2 and 3 are the data, 5 is the information, right? Now, what is the next one? Next point, process. What is process? What is a process? What is a process? The steps to
Step followed to
followed
complete a task.
complete a completed task. That means why here, what the task we have completed in that mixie jar, all those unprocessed materials we have given. Then after we run that mixie, then that materials will be processed. Okay, that means my mixie is performed the processing. Here also CPU, it performs the task. Okay, that means what? So the processor, it processes that data. The processor, it processes that data. That means what? So it is nothing but a computer task. So technical, what we can say, suppose you have written a program. You have written a program. So the program will be executed. The program will be executed inside the CPU. That means what? So process is called what? A program under execution. A program under execution is called process. Okay. After completion of that process, you will get the result or you will get the information. So what is the process? The steps to be followed to complete a computer task. Okay. Technically, what we can say? The program under execution. A program under execution is called process. The program under it. That means what? So while executing the program, so it will be done in the processor. So the program under execution is called what? Process. So here data, information and process. So the data will be processed to get the information. Okay? So here data, process and information. So this is the order we need to follow. You need to give the data as input, then after it will be processed, then only you will get the information as output. Right? So this is about data, information and process. Wait, some noise is coming. Are you getting some noise here?
Yes, ma'am.
Yes, ma'am.
Yes,
ma'am.
ma'am.
Oh, so for this one, everyone will give the response. Huh? But if I ask the questions, nobody will give the response. Huh? Okay. So how many members are there till now in your class? 53, 52. Okay. Now, so moving to the next slide. Let us move to the next slide. Okay, already we have discussed about the definition of the computer. So 3 definitions we have discussed. So here let us see what is an electronic device. So what is an electronic device? Already we have discussed. Computer is an electronic device. Computer is an electronic device. Already we have discussed. What is an electronic device? What is an electronic device? Electronic device is nothing but
which can handle
I will read.
both hardware along with electricity.
A device which can handle
Hardware and software along with electricity.
Yes, a device which can handle hardware, software along with electricity. That means what? So here we are using computer. Okay, hardware is there, software is there. If no electricity, can we able to work with the computer?
No.
Can you able to work with the computer? No, we cannot. That means what? Electricity also required. Electricity also required to work with the hardware and the software of the computer. So that's why computer is an electronic device. Why it is an electronic device? A device which can handle hardware, software along with electricity. Okay, so that's why it is an electronic device. So examples, if you take the examples, computer is an electronic device, Smartphone is also an electronic device. Okay. Now coming to the next one. Hardware. What is a hardware?
Physical
Already we
component
had
of
discussed
computer.
physical components of a computer or physical parts of the computer is a hardware. So what are the
Hardware.
examples of hardware?
CPU,
CPU, input
monitor,
devices, input devices and output devices.
Output.
What are the input devices here? Keyboard,
Keyboard,
monitor,
mouse,
Keyboard,
scanner,
mouse,
keyboard, mouse and scanner are the input devices. Output devices are
Printer.
printer,
printer, speaker,
yes,
monitor.
these are the output devices. Okay, so hardwares are nothing but physical parts of the computer. They are CPU, input devices, and output devices. Now coming to the next one, software. What is a software?
It is a collection of
It's a collection of
that allow
programs.
the hardware to do its job.
Yes, that allows the hardware to do its job. Okay. So here software is nothing but collection of programs. Then what is a program? Program is nothing but set of instructions. Set of instructions is a program. Then collection of programs is called software. Okay. Examples, if you take the examples, so operating system is a software, MS Office is a software, C++, all those things are the softwares. Okay. Now, moving to the next slide. So already this block diagram we have discussed, right?
Yes,
Have we discussed or not?
Yes,
So
madam.
input we need to give. Then after inside the CPU, there is 3 units. One is control unit. Second one is arithmetic and logical unit. Third one is memory unit. The control unit, what are the responsibilities of the control unit?
Control the system.
It controls
It
the
controls all actions of the
instructions, all the
activities of the computer. It controls the activities of the computer. Then what about arithmetic and logical unit?
It done the arithmetical and
It
logical
performs arithmetic and logical operation. Yes. Then what about memory unit?
store.
stores
Store
data.
Okay. In how many ways we can store the data? Yes. In how many ways we can store the data?
Primary storage and primary and
Primary
secondary.
storage.
primary unit and
secondary.
secondary.
Second. The primary storage is nothing but main memory.
Temporary.
Main
So in that main memory,
Temporary.
the data will be
Which-
stored temporarily.
Temporary.
That means what? If power goes up, what will happen?
Data will be removed.
The data will be erased. The data will be erased. If power goes up, the data will be erased. But in case of secondary memory, even though the power goes off, the data remains in that system. It remains in the system.
Permanent.
Okay.
CD,
It is yes. CDs, DVDs, hard disks are the examples of the secondary storage devices, right? Now see this one. Input. What is input? What is an input? Input is the data we are giving to the computer through the input devices. What are those input devices you can use to give the input? Keyboard, mouse,
Keyboard,
scanner.
scanner.
Keyboard, mouse, and scanner. Okay. So using these devices, you can give the input to the system. Then what about output? What is output? The results we are getting.
We are getting
The
on
results we are getting on the computer
On the computer
screen
screen from output.
from the output device. What are the examples of output devices here?
Monitor,
Monitor,
printer,
These are the output
Printer.
devices. Yes, through the monitor or printer, you can see the output, right? Now coming to next one. Editor. What is an editor? What is an editor? Read out any one of you.
Editor is a platform where we
Editor
can
is-
create, compile, and execute our program. Example: C, C++, Java.
That means what? Have you seen the C software in your system? So if you double click on that turbo C icon, what will happen? One blue color window will be opened. One blue color window will be opened. So that window is called text editor or editor. So in the text editor only, you can write the program. That means what editor is a platform where we can create, compile, and execute a program. That means what you can create, you can write the program, you can compile the program, then after you can execute the program. So that is called text editor or editors. Now mute your mic, I'm getting noise. Somebody has unmuted your mic. Okay. Now, so this is about editor. Next one. What is the next one?
ID.
What is next one? ID. What is ID?
ID.
Stands for what?
Integrated development
Integrated development
Integrated
environment.
development environment. So it is also a platform where we can create, integrate, and deploy the combination of more than one software. More than one software we can deploy. Okay. So what are the examples of IDE here? Eclipse, NetBeans, Edit Plus, all those things are the examples of this integrated development environment. Right? Okay, so already we have discussed. So secondly, to store the data permanently, we are using some hard disk, CDs, DVDs, floppy disk, all those things, right? So these are all called what? Disks. So these disks we are using to store the data permanently. Okay, so what are the disks we are using to store the data permanently? Hard disk, HDD, hard disk drive, then after floppy disk drive, then after optical disk drives. Okay, hard disk drive is a non-removable disk. That means from the system we cannot able to remove. But in case of floppy disk and CDs, you can remove from the CPU. Okay, you can whenever if you want to copy the data, you can insert that disk. Otherwise, after that you can after completion of your work you can remove that disk from the block. Okay, so these are the examples of the disk. One is hard disk, second one is floppy disk, third one is optical disk, CDs, DVDs, all those things are the disks we are using to store the data permanently, right? Now, coming to the next one, primary and secondary memory. Already you know very well about what is a memory, what is the difference between primary and secondary memory, right? So what is a memory here? What is a memory?
Memory is
What
a
is
computer storage area. It can be two types, primary and
yes. So memory we are using to store the data. Memory we are using to store the data. Okay. So it can be primary and secondary memory. So primary memory is nothing but volatile memory. Primary memory is nothing but volatile memory. So examples of the primary memory is what? RAM and ROM. RAM stands for what? Random access memory. ROM stands for
Read-only memory.
read-only memory. That means if power goes off, the data will be erased. But in case of secondary memory, even though the power goes off, the data will not be erased. Okay. Now let us see the differences between RAM and ROM. See the first difference. What is the first difference between RAM and ROM?
It is a primary memory.
It is a primary memory.
It is a primary
Is a primary memory. Then what about ROM?
Read-only memory.
Read-only memory. Okay. That means what it allows you only to read the data. It will not allow you to modify that data. What is the second difference? It is a temporary memory.
Or
It is called
memory.
volatile memory. But in case of ROM, it is a permanent memory and it is a non-volatile memory. And third one. So RAM is the memory available for the operating system, programs, and processes to use when the computer is running. That means when the computer is running, then only you can make use of this RAM memory. If the power goes off, what will happen? You cannot able to use that RAM, even though the data will be erased. But in case of ROM, the memory that comes with your system, the memory that comes with your computer system, that is pre-written to hold the instructions for booting up the computer. That means if you switch on the computer, what will happen? It takes some time for booting purpose. So that means what? So this is a by default, those softwares are installed in your system. That means what? So these are coming from your system only. Okay, that is ROM. Now coming to the next difference. What is next difference?
Two types of RAM.
RAM requires what it requires? RAM requires
flow of
what?
current, flow of
It
electricity.
requires flow of electricity to retain the data. It requires flow of electricity to retain the data. Okay, but in case of ROM,
Without the flow of electricity.
without flow of data, the data will be retained. That means even though flow of electricity is not available, the data will be there in the system. Okay. Now coming to the next one, how many types of RAM are there?
Two types.
What are those two types?
Static RAM, dynamic RAM.
Static RAM and dynamic RAM. Then in case of ROM, how many ROMs are there here?
Four.
What are those four types?
Masked
MROM,
ROM,
MROM, PROM,
programmable
read-only
EPROM,
memory,
and EEPROM. EEPROM. So MROM means a masked RAM, PROM means a programmable read-only memory, EPROM means a erasable and programmable read-only memory, EEPROM means a electrically erasable and programmable read-only memory.
Ma'am,
Okay. So yes, ma'am.
you can take a screenshot of these differences.
Why? I will share. I will send the PPTs. Don't worry. If you want take, you can. But I will share the PPTs. Don't worry. Okay. I will send in your WhatsApp group. Okay.
Okay.
Do you want take now?
Yes, ma'am.
Huh?
Yes, ma'am.
Okay, you can take.
Okay.
Have you taken?
Yes.
Completed? Okay.
Yes, ma'am.
So these are the differences between RAM and ROM. Okay. Now coming to the secondary memory. So what are the devices, disks we are using to store the data permanently? What are the disks?
CD, DVD,
CD disks,
CD,
DVD,
DVD, Blu-rays,
Blu-rays.
Yes. These are the disks we are using to store the data permanently. Okay. Now, so here, see the memory units here. Here, the size of the memory can be measured with the following units. What are those units? See here. So 1 kilobyte equal to 1024 bytes. Actually, 1 byte equal to 8 bits. 1 byte equal to 8 bits. Here, 1 kilobyte equal to how many bytes are there here?
1024
bytes. Okay. And 1 megabyte equal to 1024 kilobytes. 1 megabyte equal to 1024 kilobytes. 1 gigabyte equal to
024 megabyte.
1024 megabytes. 1 terabyte equal to
1024 gigabyte.
102 gigabytes. 1 petabyte equal to
1024 terabyte.
1024 terabytes. Okay, that you need to remember. 1 kilobyte equal to 1024 bytes. 1 megabyte equal to 1024 kilobytes. 1 gigabyte equal to 1024 megabytes. 1 terabyte equal to 1024 gigabytes. 1 petabyte equal to 1024 terabytes. So this is about the memory measurement units. Okay. Now, so already you know we have discussed about the process. CPU is the process. The main responsibility of the processor is what? It calculates arithmetic and logical operations. It performs billions or trillions of calculations, right? So now, so already we have discussed there is a software. We have two types of softwares. One is system software and second one is application software, right?
Application software.
Okay. Operating system is a system software or application software?
System software.
It is a system software. It is a system software. Okay. Now let us see the definition of the operating system. So an operating system is a system software that manages computer hardware and software resources. Yes,
and
it
provide
manages common services for the computer. It provides the common services for the computer. That means what? So it manages the computer hardware and also software resources, and it provides the common services for the computer. Okay. So then, so the operating system already we have discussed. It acts as an interface between the user and the computer, right? So operating system, it acts as an interface between user and the. That means if user wants to work with the computer hardware through the operating system only, that means why it is an intermediate. So through the operating system only, the user can interact with the computer. Okay, that's why it acts as an interface between user and the computer, right? And so see some functions of an operating system. So let us see what are the functions of the operating system. Memory management, processor management, device management, file management, security, control over system performance, job accounting, error detecting aids, coordination between other softwares and users. So these are some important functions of the operating system. Some important functions of the operating system. Okay. So before going to discuss about the next topic, compilers, let us see the types of operating systems we have. So, but this is not there in your syllabus, but you will try to remember. So here, batch operating system, time sharing operating system, distributed operating system, network operating system, and real-time operating systems are the types of operating systems. Okay. Now, so at the time now it is 12 o'clock, right? So up to 12:10 you have the class. Okay.
Yes, madam.
Okay. Attendance link. You are asking, we are waiting for attendance link. Wait, I will share that attendance link, don't worry. So, okay, first tell me, what's the compiler? Already we have discussed. Compiler, translator, and assembler. What are those three?
Which translates
These are
code
the
information.
translator. These are the translator. Okay. Assembler. What's the main responsibility of assembler? What is the functionality of the assembler?
Assembly code to machine code. It translates.
It converts assembly level language code into
To machine level language.
Machine level language.
Okay. It means what? Assembly level language is an example of the low level language. So in assembly level language, the machine level language instructions assigned to the code. That means what? So if it is in the form of assembly level language, instead of zeros and ones, if you use some mnemonics to give the instructions, so those code, that those symbols will be converted into machine code by the with the help of assembler. Okay. Now what is a compiler?
A translator which converts
is
high level
translated.
language.
Which converts a high level language code into machine level
Low
language.
level.
Okay. But it converts a entire program at a time. It converts a entire program at a time. But in case of interpreter,
Line
Line
by
by
line.
line.
line by line will be converted. Line by line will be converted. This interpreter we are using to convert JavaScript to PHP shell scripts into machine code. JavaScript, PHP, and shell scripts to convert into machine code. Okay. But compilers we are using to convert to C, C++, Java language into machine code. Language program into machine code. So this is the difference between compilers and interpreters. Okay. So tomorrow we are let us discuss how to create, compile, and execute a C program. All those things tomorrow we can discuss these diagrams and all those things. Okay.